Welcome, everyone. Today we're delving into direct air capture, or DAC, a technology that's gaining attention in the fight against climate change. I'm Aiden, alongside Sandy, and we're here to explore DAC's intricacies, its promise, and the hurdles it faces.
Right. DAC has even been called a technology that can reverse the clock on climate change. But what is it? DAC is a negative carbon emissions technology that removes carbon dioxide, or CO2, from the atmosphere. DAC uses a chemical process to filter the gas from the air and heavily relies on the use of sorbents. There are two main forms of DAC that people generally divide the technology into: passive forms and active forms. With passive DAC, the technology relies on passive or natural airflow to help capture CO2, which has opportunities to save money and energy, since the other form, active DAC, sucks air in to help capture CO2, which requires more energy and money as a result. In short, DAC is about cleaning up what's already been released, even years after it was emitted.
That's what makes DAC so different from other carbon capture technologies and solutions to manage climate change. Once CO2 has been captured, it can be stored underground in geological formations or even turned into new products like jet fuel and concrete.
That's a big deal because CO2 is the main gas behind climate change. It absorbs and radiates heat, and an abundance of it is making the Earth hotter. That means more unpredictable weather patterns, rising sea levels, and vulnerable species dying off.
Despite global efforts to reduce CO2 levels and reach net zero emissions, humans produce about 35 billion tons of CO2 annually. For scale, that's the weight of more than 155,000 statues of Liberty added to the atmosphere every year.
Natural carbon sinks like oceans and forests help to store some of the CO2, but they are having a harder time keeping up with emissions. CO2 can stay in the atmosphere for 300 to 1,000 years, which means that we are compounding on the amount already out in the atmosphere every year. Removing carbon from the air is not just an environmental concern, it's also a global health concern. And conversations around DAC typically lack any acknowledgement of how carbon emissions affect individual health outcomes across the globe. Rising levels of CO2 can cause headaches, drowsiness, increased heart rates, oxygen deprivation, and other major health concerns.
It's simply not enough to cut down on the emissions to curb the effects of climate change. We need to actively remove hundreds of millions or even 1 billion tons of CO2 from the air every year. And you might be asking, why don't we plant more trees? Well, we do. But the reality is that we literally can't grow our way out of climate change. We need millions of acres of land that aren't available. Plus, trees alone can't keep up with the rate that CO2 is being produced. Like DAC, reforestation is one of many approaches we need at the same time.
And that's a stark reminder of the challenges we face. And while DAC offers hope, it's not without its complexities.
High cost and energy requirements have made it difficult to scale DAC technologies. Even though the industrial capacity exists, 2024 estimates put the cost of CO2 removal through DAC at $400 to $1,000 per metric ton.
To understand the technology further, we spoke to Dr. Klaus Lackner, a physicist, co-founder of the Center for Negative Carbon Emissions and pioneer of the field.
I do think of the climate change issue as largely a waste management problem. We are dumping untold numbers of carbon into the atmosphere, and we need to balance the books. And direct air capture is one tool in that toolbox. My personal view on this is direct air capture either will work or will not work. And if it works, it's likely to play a role, maybe not 100%, but at least 10% or more. And because on the other hand, if direct air capture doesn't exist, because we couldn't make it work, climate change will really hurt.
There's also the question of what to do with the CO2 that's been captured through DAC. Storing it underground is a common strategy because it's seen as safe and permanent. Yet there's concerns about long-term impacts and choosing specific storage locations.
Despite these challenges, there's a growing network of actors involved in DAC. They represent private, academic, nonprofit, and government sectors that are working together to bridge the gap between evolving challenges and solutions. That includes basic research and marketing the technology. This diverse landscape of contributors emphasizes the complexity and potential of DAC.
The U.S. Department of Energy, for example, awarded funding for 19 projects to create regional direct air capture hubs. This program aims to grow the technology to commercial scale. It was part of the $3.5 billion invested into the hubs from the bipartisan infrastructure law passed by Congress in 2021. Arizona State University receives part of the funds to design a hub in the Southwest. The university is already home to the Center for Negative Carbon Emissions, which advances technologies to manage CO2.
Every day we're discovering and studying new materials that can lower energy requirements, that can produce higher amounts of CO2. We're looking at ways to manufacture that material and package it and present it to the air in such a way that we can improve the kinetics and the capacity of those materials.
There's many different ways that you can actually pull carbon dioxide out of the air. Here at the Center for Negative Carbon Emissions, we've narrowed our focus down to just a few. The primary two that we focus on involve a cycle that involves moisture. So this can be humid air or water, but that water is critical to the capture and controlled release of carbon dioxide.
The center has a partnership with private company Carbon Collect, and with research led by Dr. Lackner, they invented the mechanical tree. It's the first commercially scalable technology that can passively collect CO2. When its column extends, air passes through and allows CO2 to stick to the special discs with the help of sorbents. As of 2024, 19 DAC plants are operational worldwide, with many more in production. There are facilities dedicated to removing CO2 from the air at a commercial level.
In the U.S., Heirloom Carbon Technologies opened the first commercial DAC plant. It was supported by federal funding and demonstrates the potential for DAC to become part of the broader strategy against climate change.
You need to figure out that interaction between technology and policy, because the technology won't develop without the policy, and the policy really can't step forward without the technology. So that's a conundrum.
The journey ahead is filled with both promise and challenges. Embracing technologies like DAC requires a nuanced understanding that balances optimism with the reality about the challenges ahead.
The direction of climate change depends on the work happening every day, but one thing is clear: it will take international, private, and public sector coordination to work.
Thank you for joining us on this exploration. We're Aiden and Sandy, encouraging you to stay curious, stay informed, and keep the conversation going.
Together, we can navigate the complexities of climate solutions.